Hello friends and welcome to your channel Gate Questions EC. So I am back with next question in this series of random variable, and the question is, consider n independent and identically distributed random variables x1 up to xn such that x1 is uniformly distributed over interval. If z is equal to maximum among x1, x2, x3 up to xn, then find the expression of the following. First is PDF and CDF of z. Second is expectation of z, and third is variance of z. We have done a similar question, question number 116, but in that question x1 was uniformly distributed over 0 to 1, and I gave the practice question also in which x1 was uniformly distributed over -1 to 1. So following the same method that we used in that question, we will solve this question. So in the solution of this problem, we will use the formulas that we derived in question number 106 and question number 111. So those who haven't watched those questions, I request them to go and watch those questions first, and only after that proceed to the solution. We know that if z is equal to maximum among n independent and identically distributed random variables x1, x2, x3 up to xn, and these are independent and identically distributed, then we know that the CDF of z for a sample value small z is related to the CDF of any of these n random variables. I am taking random variable x1 for sample value z raised to power n, and similarly the PDF of z, which will be the differentiation of this, so it will be n times the CDF of x1 for sample value z raised to power n minus 1 times the PDF of x1 for sample value z. And it is given in question that x1 is uniformly distributed over range A to B. So this is the PDF of x1. Suppose this is the origin, and this is the PDF of x1 for sample value small x1. So its height will be 1 over b minus a. This I am writing as 1 by delta. So the CDF of this x1 will be the integration of its PDF. So you can draw it here. So integration of the constant value will be the straight line with slope 1 over delta. So from A to B, it will be a straight line, and after B, its value will be constant and it will be equal to 1. So this is the CDF of this f of x1. You can write it mathematically. F of x1 will be equal to x1 minus a divided by b minus a in range when x1 is greater than a and less than b, and it will be equal to 1 for, here you can write less than equal to, and it will be equal to 1 for x1 greater than equal to b. Similarly, we can write mathematically the CDF of x1 will be equal to 1 over b minus a in range x1 greater than a less than b, and otherwise it will be 0. So putting these two mathematical equations in these two equations, we will get the CDF of z will be, so in place of this we will have to write, in place of x1 we will have to write z. So it will be z minus a divided by b minus a, which is delta raised to power n. And similarly, the PDF of Z will be N times the CDF, that will be Z minus A by delta raised to power N minus 1 times, this is 1 by delta, where Z varies from A to B. Also, in this expression also, Z can vary from A to B. And above B, so Z greater than equal to B, this will be equal to 1. And similarly, the PDF of Z will be non-zero only in this range, and otherwise it will be 0. So we can write it will be 0 otherwise, or for all other values of Z which are not in this range. So this is the PDF of Z and this is the CDF of Z. So this is the answer to our first part, part A, in which we have to find PDF and CDF. So now let's solve the part B. So in part B, we have to evaluate the expectation of Z. So that will be equal to integration from minus infinity to plus infinity, sample value small z, PDF of Z, dz. So now we can put this value of PDF in this expression and evaluate the expectation of Z. So putting the value of PDF, we will get integration limits will change from A to B and Z times N. So you can see here delta raised to power N minus 1 and here delta is also power 1. So this will become delta raised to power N. So that we can write N by delta raised to power N times Z minus A power N minus 1 dz. So these two terms are constant, so we can take it out of the integration. So this will be equal to N by delta raised to power N integration of A to B Z times Z minus A raised to power N minus 1 dz. So this will be equal to N by delta raised to power N, and we will solve this by parts. We will integrate it by parts. So that will give us Z times Z minus A raised to power N minus 1 plus 1. So that will be N divided by N minus integration A to B differentiation of first term. The first term is Z. Its differentiation will be 1 times this term. So that will give Z minus A power N divided by N dz. And its limits can vary from A to B. So that will be equal to N by delta raised to power N. So putting B here, this will become B, and here B minus A, that we can write delta. So delta raised to power N divided by N. And if you put the lower limit A here, so the whole term will be 0. So that is the first term minus integration of this will be Z minus A raised to power N plus 1 divided by N is already there times N plus 1, lower limit A, upper limit B. So you can solve this and we will get N over delta raised to power N B delta raised to power N divided by N minus, if we put here upper limit B, so this will become B minus A, which is delta. So it will become delta raised to power N plus 1 divided by N into N plus 1 minus lower limit. So lower limit is A, and if we put here, so this will become 0. So here it will be 0. So this we can further solve. Multiplying this term inside, we will get b minus, and here we will get delta divided by n plus 1. So this is the expectation of z, where z is maximum among all n independent random variables. I will request you all to memorize this result for faster calculations in solving such questions. So now let's see the part C, in which we will have to calculate the variance of z. As we know, variance of z is equal to expectation of z square minus expectation of z square. This term expectation of z we have already calculated, so we need to calculate expectation of z square to calculate variance. So firstly, let's calculate expectation of z square. So that we can write integration minus infinity to plus infinity z square fz of z dz. So putting here the PDF of z, we will get integration from a to b z square times n by delta raised to power n z minus a power n bracket dz. So this will be equal to n by delta raised to power n integration a to b z square z minus a power n minus 1 dz. So this is equal to n by delta raised to power n. So integrating by parts again, we will get z square. So integration of this will be z minus a raised to power n by n. Lower limit will be a, upper limit b, minus integration, differentiation of this will be 2z. So taking 2 out, z times this whole thing, z minus a raised to power n divided by n dz, where limits is from a to b. So this will be equal to n by delta raised to power n. So putting upper limit here, we will get b square. B minus a will be delta. So delta raised to power n divided by n, and putting lower limits, we will get 0 term. So it will be minus 2 divided by n, so 2 by n integration a to b z times z minus a raised to power n dz. So multiplying this term inside this bracket, we will get b square minus 2 by delta raised to power n, and integral of this will be, so first term, integration of second term will be z minus a raised to power n plus 1 divided by n plus 1, minus integration of differentiation of this will be 1, and integration of this term z minus a raised to power n plus 1 divided by n plus 1 dz, and here limits will be from a to b. So this will be equal to b square minus 2 by delta raised to power n times, so upper limit we put here, it will give us b times delta raised to power n plus 1 divided by n plus 1, and if you put lower limit here, it will be 0. So it will be equal to minus integration of this will be z minus a raised to power n plus 2 divided by n plus 2. So that will give us z minus a raised to power n plus 2 divided by n plus 1 times n plus 2, lower limit a, upper limit b. So this is equal to b square minus 2 by delta raised to power n b delta raised to power n plus 1 divided by n plus 1 minus, so putting up a limit here, this will give us delta raised to power n plus 2 divided by n plus 1 n plus 2, and if you put lower limit it will give us 0. We will get b square minus 2 times, so taking delta square inside and n plus 1 common outside, it will give us n plus 1 times b delta minus delta square divided by n plus 2. So we can take delta common here, so it will be equal to b square minus 2 over n plus 1 delta b minus delta by n plus 2. So this is the expectation of z square. Now we will put this expectation of z square in calculation of variance. So variance of z is expectation of z square minus expectation of z whole square. So that will be b minus 2 delta upon n plus 1 b minus delta by n plus 2 minus expectation of z, which we calculated was b minus delta upon n plus 1 whole square. So we open this square term and multiply and open this bracket term also. That will give us 2 delta b upon n plus 1. So minus minus will get plus 2 delta square upon n plus 1 n plus 2 minus b square minus delta square upon n plus 1 whole square plus 2b delta upon n plus 1. So this term will cancel out this term and this term will cancel out this term. So remaining will be delta square we can take common, and n plus 1 also we can take common, and remaining terms are 2 by n plus 2 minus 1 by n plus 1. So you take LCM, so that will give us bracket, LCM is n plus 2 n plus 1. So 2n plus 1 will be 2n plus 2 minus n minus 2. So 2 and 2 will get cancelled and 2n minus n will give us n. So the final result for the variance of z is delta square times n over n plus 1 whole square times n plus 2. So I will request you all to memorize this for faster calculation in numericals. Let me write the formula for the expectation of z also. So we calculated it earlier and it was b minus delta upon n plus 1. So we can directly use these two formula for expectation and variance calculation for z, where z is maximum among the n independent random variables which are independent and identically distributed. So let's do some practice on these formulas and rediscuss the question number 114 and question number 116 that we have discussed earlier. So let's see first question number 114. So this is the question number 114 that we discussed earlier in earlier videos. You can see here z is maximum among 3 random variables which are uniformly distributed over 0 to 1, and all these 3 are independent and identically distributed random variables. In the C and D part, we can directly calculate by using these formulas. So in this question, n is 3 because there are 3 random variables. Also here x1 is uniformly distributed over interval 0 to 1. So here A is 0 and B is 1. So using the formula for expectation of z, we can see the answer will be b minus del upon n plus 1. So that will give us 1 minus del is again 1 upon n plus 1. So that will be n upon n plus 1, which is the same answer that we obtained while discussing question number 114. Similarly, we can calculate the variance of z will be equal to, so del square n upon n plus 1 whole square n plus 2, and here n is 3. So that will give us del square, which is 1 square times 3 upon 3 plus 1 4 square times 5. So the answer will be 3 upon 16 times 5. That will give us 3 by 80. So this is also the same answer that we obtained while we discussed this question. At the end of the video on question number 114, I gave a practice exercise also. So let's see that practice exercise also. So this is the practice question that I gave. In this question, z is maximum among these three independent and identically distributed random variables. And here x1 is uniformly distributed from -1 to 1. So here a is -1 and b is 1. And also here n is 3. So we can directly solve part C and D. So del for this question is b minus a, which is 1 minus -1. So that is 2. So the expectation of z will be b minus del upon n plus 1. So that will be 1 minus delta, which is 2, upon n is 3 plus 1. So that will give 4. So 1 minus 1 by 2, answer is 1 by 2. Similarly, the variance of z we can calculate is del square n upon n plus 1 whole square n plus 2. So that will be equal to del square is 2 square 4 times 3 upon 4 square, which is 16, multiplied by 5. So that is 4 will cancel out, 3 by 20. So 3 by 20 is the answer for the D part. So now let's see question number 116. So in this question, we have n independent and identically distributed random variables where z is maximum among all these n independent and identically distributed random variables. So here a is 0 and b is 1. So we can calculate expectation of z will be 1 minus delta is 1 upon n plus 1. So that will give us n upon n plus 1. So the variance of z we can calculate will be del square. Here del is 1. So 1 square times n upon n plus 1 whole square times n plus 2. So this is the answer for the expectation and variance of z. So similarly, I gave a practice question in this question also. So let's see that practice question also. So this is the practice question, and in this we have a as -1 and b as 1. So delta here is 2. So expectation of z will be b minus delta is 2 upon n plus 1. So that will give us n plus 1, n plus 1 minus 2. That is n minus 1 upon n plus 1. And the variance of z will be delta square. That will give us 4 times n upon n plus 1 whole square times n plus 2. So these are the answers for the expectation and variance of z. So I hope you have learned how to handle such questions in GATE exam if they appear. And in the GATE exam, they will not ask you to find the PDF and the CDF. They will directly ask you these form of questions. So in the end, I will like to thank you all for keeping the patience and watching this video till end. So if you like this video, then please do press that like button below this video and subscribe to my channel for more such videos in future also.